Bonjour, welcome to Wahsa Distance Education Center's radio Zoom classes. This is MBF3C, grade 11 college math, and I am the teacher, Bronwyn Slade. If you'd like to participate live, you can call the Wahsa studio at 1-800-465-7144 or 737-4017. You can listen on the radio at 91.9 FM and also on the television at Bell Express View channel 972. You are always welcome to join me live through the Zoom link, which is available both from me, your teacher, and also your DEC. Our classes are scheduled Monday through Thursday from 10 until 11 in the morning, and we are in our third week of our 9-week course. At this point, you should be thinking about submitting some work for marking. So a reminder that the support questions, the ones with a little pencil icon, are not for marking. These are practice problems. So you decide which ones and how many of them to do. If you're understanding a concept, it is totally okay to skip questions. You know yourself best in terms of what tools you need to practice and what skills you have. The answers are in the back of your book, so check your work. It's a good idea to do at least some of the practice problems to make sure you're on the right track and check your work from the back. But then you can go from there in terms of what you need to do. The key questions, however, are the ones with a little key icon, and these are the ones to submit for marking. So these ones you need to do all of the questions, showing all of your work, your steps, and your thinking. This way I can give you marks for all of your understanding. And if you are making a mistake, possibly you'll have only lose part marks if I can figure out where your mistake was. If you just give me the answer and you have the wrong answer, then you don't get any part marks because I have no idea where the answer came from. So how do you submit your work for marking? Well, there's 3 methods. The first is to scan your work and send it electronically. If you have a device, you can scan it. The Apple devices come with a Notes app that has a scan function, and the Android devices come with a Google Drive app that has a scan function. These are free apps for some reason you don't have them and are really easy to download and access. If you need some support about figuring out how to actually scan using them, I have tech tutorial videos on my YouTube channel that will walk you through step by step how to actually use these scanning functions. If you need more support, let me know. I'm happy to support you. Then you can send them to me through email to studentwork@nnec.on.ca and CC them to bronwyn.slate@nnec.on.ca. Or you can also send them to me through Facebook Messenger, where my name is bSlateWahsa. The second method is to drop your work off in Sioux Lookout. We have an outdoor mailbox at 74 Front Street. We are the bright red building next to the post office, and we have a small white mailbox next to our side entrance. The third method is to hand your work into your DEC. Your DEC can either send your work through the Express or fax it to 807-737-1732 or toll-free fax to 1-800-463-7852. Students can also fax in their work. Just give us a heads up that it's coming, as sometimes things go missing. If you'd like to connect with me through social media, both my Facebook and my YouTube channel are under the name bSlateWahsa. So you can find me on Facebook and subscribe to my YouTube channel, and then you'll get notifications every time I upload one of our new videos. All of our radio Zoom classes are recorded, and I post them to YouTube shortly after broadcasting. Also, there are short videos that explain common errors and confusing concepts there that will help you if you're struggling with something. Math is an incredibly visual subject, so I strongly encourage you to access the videos. Either joining me live through Zoom, whether or not you want to talk to me, you don't have to, that's totally fine, or watching the YouTube videos at your own time. That works for me too. If you don't have access to those options, you don't have reliable internet or something like that, please just let me know, and I'm happy to send you a copy of the recordings so you still get the full experience and really set yourself up for success. So if you have any questions or concerns, please reach out and connect with me. My email address is bronwyn.slate@nnec.on.ca. My Facebook is bSlateWahsa. Call me at the office at 807-737-1488, extension 2209, or toll free 1-800-667-3703. My office hours are Monday through Friday, 8 a.m. to 2 p.m., though I teach from 9 to 11, so that is not a good time to try to get a hold of me. Today's lesson is the first in Unit 2. This is Lesson 6, which is looking at simple interest and linear growth. Our learning goals for this lesson are that at the end, you will be able to problem solve using simple interest, and you'll understand the relationship between simple interest, arithmetic sequences, and linear growth. You know you've met these learning goals because you can explain the connections between simple interest and linear growth in arithmetic sequences, and you can identify what information is available in a real life situation involving simple interest, and then you can calculate the missing element. When will you use this in real life? Well, we're examining patterns. Patterns are something that show up everywhere in our society. And so being able to see them and then extrapolate information, being able to figure out things because of the patterns that you see is a really, really useful skill. But first, let's activate our brain with some mental math. I don't believe in mad math minutes. They are stressful and creates anxiety in more students than not. And they don't teach you any actual skills in my experience. They rely on memorization and speed, which are not actually values of math education. So instead, we work on developing strategies that use friendly numbers and tactics that you're comfortable and confident with in order to complete arithmetic in various situations. Our question today is 216 divided by 48, and we're going to be using the concept of proportional reasoning. So proportional reasoning is the idea that if we break both the dividend and the divisor, so the amount that the amount of things that we have in total and the amount of groups that we are making, if we break them up in both into the same amount, then this could be the same as what we already have. So let's show you what I mean. So what we're going to do is I'm going to cut both these numbers in half, because say I have 216 marshmallows is the thing that comes in my mind, and I want to split them up into 48 groups, 48 people, but I don't know how many each they get. Well, if I first think, okay, well, only half of my marshmallows is 108 marshmallows, and half of my people is 24 people, I still have 108 marshmallows left for the other 24 people. I'm just thinking about this 24 first. And that's how we could do it. We don't just have to do it by 2, we could do it by different numbers, but we're going to start by doing it with 2, and then I'm going to do it again. It's kind of like doubling and halving, but actually I'm dividing both sides by 2 in order to figure out those proportions. So 108 divided by 2, well, 100 divided by 2 is 50, 8 divided by 2 is 4, so 108 divided by 2 is 54, 24 cut in half is 12. And I can still cut it in half. Even though it is maybe not the most efficient way, it isn't about efficiency. It isn't about being the fastest. It's about making it make sense. So once again, I can cut both these numbers in half. They're both even numbers. So 54 cut in half, well, 50 cut in half is 25. 4 cut in half is 2. So 54 cut in half is going to be 27. 12 cut in half is 6. So now 27 is an odd number, so I can't cut it in half, but I know that 27 is divisible by 3. So this time I'm going to divide both these numbers by 3 to make my group smaller. So if I divide 6 by 3, I get 2. And if I divide 27 by 3, I get 9. And now 9 divided by 2, that isn't going to give me a whole number, but I know that half of 9 is 4.5. So I know that 9 divided by 2 is 4.5. And these are all the same thing. So that just means that for every person, they get 4.5 marshmallows. And it doesn't matter if I'm talking about one person or if I'm talking about 48 people, everybody still gets 4.5 marshmallows. And that will add up to a total. If I combine all that up, I will get 216. I'll use up all my 216 marshmallows or whatever. And that's how proportional reasoning can be a really useful tool for doing division. So what prior learning do we need to know for today's lesson? I just want to go over again converting percentages to make sure that we're all on the same page, as this is incredibly important to be able to do accurately when we are dealing with finances and money. So remember, percent comes from the Latin word by the 100, which means we're dividing by 100. It's whatever the number is per 100, that's the ratio we're comparing it to. So for example, if we have 7%, we do 7 divided by 100, and that is equal to 0.07. If we have 12%, that is 12 divided by 100, which is 0.12. If we have 1.25%, that is 1.25 divided by 100, which is 0.0125. If we have 3.5%, that is 3.5 divided by 100, which is equal to 0.035. 24.75% is 24.75 divided by 100, which is 0.2475. 19.83% is equal to 19.83 divided by 100, which is 0.1983. So you can see the pattern potentially. Either you can just always divide your percentage by 100 and then write down what your decimal is. That is totally fine. Or you'll notice that our numbers, so 7% is equal to, you can take your decimal point, this is probably what you were taught in elementary school, and dividing by 100 means that you move it over 2 places to the left, and you draw it there, and then you fill in zeros for any of the spaces. So 7% is equal to 0.07. Or 12% is equal to 12, and then you move it over 2 spaces. You don't have any zeros this time, so it's just 0.12. If you already have a decimal in your percentage, so 19.83% is equal to, well, we want to move that decimal place 2 spots to the left, and so we end up with 0.1983. So if this way helps you remember and that works, totally go for it. If dividing by 100 is how you need to do it, that is also completely accurate. They're technically the same thing. This is just sort of a visual way of thinking about it, whereas this is a mathematical way of thinking about it, like more of a numerical way. Also, you just over time, if you get comfortable with it and you just end up seeing them and you know how it works, that's fine too, whatever works best for you. I also want to remind you what makes a year in terms of days, months, and weeks. So 1 year is equal to 12 months, which is equal to 52 weeks, which is equal to 365 days. We always do 365 days. It doesn't matter if it is a leap year or not. We always do 365 days when we're talking about financial situations and time. Okay, so it's just important to remember that those are the conversions that in order to talk about equivalency, that 1 year is equal to 12 months, 52 weeks, or 365 days. All right, so that's what we need to know, but now what are we going to learn? Let's look at some new concepts. This kind of math is all around us. Financial math is everywhere. We live in capitalist systems, so money makes our world go around. So these are things to think about when looking at interest, when we're looking at car loans, when we're looking at mortgages, so paying for a house, when you are investing and looking at bonds, even if you're like doing an installment loan through a place like buying out an appliance or a couch or a treadmill or all sorts of places where they say you can do 6 easy payments of blah, 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 blah. This is probably calculating interest part of that. And that is part of how they are making money off of you. So it's really important to understand. First, we're going to look at some vocabulary to make sure that we're all talking and understanding the same language. So simple interest is when only the money invested or borrowed earns interest. So only the money that you're starting with. So the amount of money that you borrow at the beginning, doesn't matter how long you're paying it back, you're only paying interest on that amount of money that you borrowed. If you're investing money, only the amount of money you initially invested is what's going to earn any interest. The principal is the amount of money that you borrow or invest. The interest rate is the percent of the principal that is earned or paid as interest. The amount is the sum of the principal and the interest. So this is how much you have altogether. So exploring simple interest. Suppose that you invest $1,000 that earns simple interest at a rate of 5% per annum. So we're going to figure out what this means. How much interest would you earn in the first year? What amount would you have after 1 year? So how simple interest works is that it just says that every year you're getting 5% of what you invested back. So we do our $1,000 times our 5%. Remember, 5%, we can just do 5%. So if we're calculating this though, we're going to do 1,000 times 0.05. That's a percentage we're always calculating using the decimal. And if you press your percentage button on your calculator, that's what it's going to do. It's going to say 5% is equal to 0.05. That's what it's going to use to calculate. So this is $50. So in our first year, we would earn $50 because we're earning 5% of our total investment. So what amount would you have after 1 year? Well, we would have our principal, which is 1,000, plus our interest, which is 50. So we'd have $1,050. And that's how much money we'd have after our first year. So how much interest would you earn in the second year? So with simple interest, we are earning interest on the amount that we invest. So it doesn't matter what year it is, we are doing 1,000 times 5%, which is 1,000 times 0.05, which is $50. And how much interest would you have altogether after 2 years? So this is asking how much interest. So it's important to ask answer the question that was given. So in year 1, we earned $50. In year 2, we earned $50. That means now at the end of year 2, we've earned $100 altogether in interest. So what would your amount be after 2 years? So you have your principal amount, $1,000 is what you invested, plus your $100, which is your 50 plus your 50 from the 2 years. So you'd have $1,100. And that's how simple interest works, is that you just get that percentage that your percentage rate for every year that you invest. So now we're going to complete the table for 10 years for $1,000 invested with simple interest at a rate of 5% per annum. So the same thing, but now we're just going to look at it at 10 years and organize it in a chart. So we have our number of years. So we have year 1, and we'll go down all the way to year 10. We have our principal, so how much money we invested. We have our interest, how much money we earned in that year. We have our total interest, how much interest we've earned in total since the beginning. And then we have our amount, which is currently how much money we have in total. So from year 2, our principal is still $1,000. Our interest is $50. That's how much we earned this year. Our total interest is $100. That's how much we've earned in total through the whole investment. So that means we now have a total amount of $1,100. So then we can continue doing the same thing for year 3, year 4, year 5, all the way up to year 10. We can see that our principal is always the same. We always have $1,000. That's how much we invested. So it's always the same. That means that every year we always make the same. We always make $50. So our total interest, well, it's increasing by 50 every year because every year we're adding another $50 in interest. And that means that our amount is increasing by $50 every year. So number 3, we're going to plot this on a graph, and we're going to compare it to the amount of time. So we're going to comparing the final amount to the amount of time that we invested for. You can do this on Desmos, you can do this by hand, whatever works for you. If you need graph paper, let us know. We can send you graph paper. You don't have to use graph paper. You can do a rough sketch, though using graph paper helps to see what's going on. So here you can see I have graphed all of my points. So I have up to 10 years, I have up to $15,000. And at year one, I have, at year one, I have $1,050. Year two, I have $1,100. Year three, $1,150. And they continue going up every year, $50. So if we draw a line through this, we can see that we have a straight line because we're increasing at a constant rate. We're adding $50 every single time. So then what patterns are we noticing as we're looking at these details? So we have our table of values, we have our graph. So I'm noticing that as we increase 1 year, we increase $50. That is the pattern. Every year it's the same. We always increase $50 for every year that we increase. So simple interest is both an arithmetic sequence, meaning that we're adding the same amount every time, right? We're adding $50 every time, and linear growth. We are growing at a constant rate. We are growing at that speed of $50 per year for this example, and that's a constant rate. That doesn't change. We always have $50 every year. We're always getting bigger by 1 year. As time moves forward 1 year, we are increased by $50. So the pattern increases. So both for the arithmetic sequence and linear growth, this is the same. This is how it's connected. The pattern increases, or it could decrease if we were paying back a loan at a constant rate. It's always the same every time. So this is all understanding and making connections before we even have dived into your IEL booklet. So your IEL booklet dives straight into the formula. And I think it's important to just have a little bit of an understanding before we get to the formula. So the formula is I equals PRT. And this is introduced to you on page 2 of your IEL booklet. And this is where we're going to now explore a little bit more. So what these variables mean, I is equal to your interest earned. We label it as capital I in this situation. And this is in dollars. So how much money we've earned for however many years we're doing this. P, you do a capital P, is your principal invested or borrowed. So your money and borrowed. And it is the amount of money that you start with. Your R is your interest rate per year. So it has to be, it'll say it per year, per annum, yearly, things like that. And it's expressed as a decimal in our formula. In your question, it's most likely going to give you a percentage rate. In situations, it's going to be a percentage. But when we're doing the actual calculation, we need it to be as a decimal. And T is your time in years. Sorry, this is a small r and a small t. So T has to be per year, whether or not you're doing it for a whole year or you're doing it for more than one whole year. You're doing it for less than a year. It has to be, we're calculated in the context of a whole year. So we might have to convert things. So we'll look at that. When we say I equals PRT, remember when we have variables next to each other, they are multiplying together. So it's P times R times T. We just don't write, mathematicians, I like to say, are lazy, and we just don't write down the signs or say the words. We make the assumption that you know what we're talking about. Sorry. So time broken down, we're going to go back to this piece that we talked about in terms of converting time. Once again, time must be represented in years. This is super important. So for converting, sometimes we need to convert the time that we have to the number of years. So if we have 12 months is equal to 1 year, remember, if our time period that we're investing for is 21 months, that means we do 21 divided by 12 is equal to 1.75 years. So we're going to, in our calculations, we're going to be using 1.75 because that's how many years 21 months is. If we're looking at weeks, remember 52 weeks is equal to 1 year. So if we have 45 weeks that we're borrowing money for, then we do 45 divided by 52, which is equal to 0.87 years. So in our calculations, we would use T, we would put 0.87. Or if it's done by days, remember 365 days is equal to a year. So if we were investing or borrowing for 550 days, then we do 550 divided by 365, which is equal to 1.5 years. Okay, so how do we actually calculate I equals PRT? How do we actually calculate simple interest? We're going to look at a few examples. So find the simple interest and the amount. We're given a situation. I've just given us just the straight numbers to start with. So principal is equal to $640. The rate is 12.5% per annum. Per annum is another way to say per year. And the time is 6 months. So the first thing we need to do is we need to make sure that these are all in the forms that we need. So our rate needs to be as a decimal. So 12.5% is equal to 0.0125. So that is the number I'm going to use for R. And time is 6 months. Well, that means I need it to be per year, right? So 6 months, we do 6 divided by 12 because there's 12 months per year, and that's 0.5 years. So T is going to be 0.5 and R is going to be 0.0125. So then this is asking us to do two things, simple interest and amount. So I like to label things. You can either say, you can actually write simple interest, or even if you just put down your formula, I equals PRT, I know that most likely you would know that you're calculating simple interest right now. So then we're going to put in our variables. So, or we're going to fill in our variables. So PRT is principal 640 times rate 0.0125 times time, which is 0.5. Also remember that brackets next to brackets means multiplication. It's another mathematical practice that we do. So we have going to use our calculator. 640 times 0.0125 times 0.5, which is equal to $4. So our simple interest that we've earned in the 6 months period is $4. So then we have to look, do we answer the question? No, we also need the amount. So either labeling an amount or saying A equals P plus I, the same. We have principal 640 plus interest $4 is $644. So now I see that we calculate interest and the final amount. And that's all we need to do for this question. All right. Sometimes our situation is different. So this question says, find the principal when. So we know the simple interest is $2,000. That means that that's how much money we earned. We earned $2,000. So that, in this case, is not our P, that is our I. Our rate is 2% per annum, so that 0.02 is equal to R. And our time is 20 months. So 20 divided by 12 is equal to 1 and 1.33 equals T. Right. Yes, no, 1 over, that's okay. It's just, when in doubt, use your calculator if your brain. 1.66, that's what I thought after I did 0.33. See, mistakes happen all the time. No worries. Okay, better to check. 1.67 is equal to T. Okay, so to find our principal is what this question is asking. We're still going to start with the same formula. We're going to equal I equals P RT. And we're going to fill in what we know. So we know our I is $2,000. We don't know our P, so we're going to leave it as a variable. We know our R is 0.02, and we know our T is 1.67. So now what we're going to do is we're going to isolate for P. And because I am multiplying by P by 0.02 and 1.67, that means I'm going to divide both sides by 0.02 and 1.67. This is just algebra, which crops up everywhere. So now P is going to be equal to 2000 divided by 0.02 times 1.67. So then we are going to do that on our calculator. Divided by, and as always, you need to know how your calculator works. So do you need to put brackets in? Do you not need to put brackets in? On Desmos here, I don't need to put brackets in. You can see that I'm dividing by both of these numbers, multiplying. I'm not dividing first and then multiplying. It's arranged the way I want it to be. So that's $59,880.24. 59,880.24. So in order to earn $2,000 in 20 months, you'd have to invest at 2% interest. You'd have to invest $59,880.24. So that's, we can figure out the principal if we know our other three variables. All right, number 3, find the rate. Okay, so we can also figure out what the rate is. Again, we're looking at the information that we're given. So principal is $9,600, so that's our P. Our time is 3 months, so 3 divided by 12, so that's 1/4, so that's 0.25 is equal to our time. And our simple interest is 72, so that is your I. So again, we're going to write our formula out so we can fill in what we know and what we don't know. We know our I again this time, so that's $72. Our principal this time we know is $9,600. Our time we know, our rate we don't know, so we're gonna leave our rate as R. Our time we know is 0.025. So again, we're gonna have to divide our interest amount by our 2 other variables. And this is another way. I'm writing it this way. Might work for you instead of writing it out and dividing both sides, but I've still divided both sides of it. I just then canceled it and skipped that step. So you can figure out how writing it down makes the most sense for you. If you need to write down all the steps in order for you to not lose steps, in order for you to make sure you have all the information, that is completely fine. You do not need to be lazy. You do not need to skip steps. You don't, that's fine. Sometimes I do for sake of time and because I might be lazy. So R is equal to 0.03. But do we generally leave R as a decimal? No, we want it as a percent. So if we times that by 100, R is equal to 3%. And so we can find the rate as well. And then finally, we can find the time. So when the principal is 700, so our rate is 18% per annum. So that's 0.18 is equal to our R. And our interest is $78. So again, we're going to use the same formula. Even though we're finding time this time, we're still talking about simple interest. So that means that this is the formula we have to use. And then we fill in what we don't know. 78. Sorry, I did that badly. 78 equals 700 times 0.18 times T. So again, can divide both sides by this amount. This is another way you could write it. You also could do the 700 times 0.18 first if you wanted to. You figured out what makes sense for you. So 78 divided by 700 times 0.18 is equal to 0.619. Now that is not a very friendly number. Can't even think about what that, like, it's at 0.619 years, right? Because time is always in years. So if we wanted to, we could do 0.619 times 12, which gives us that at 7.4 months. We also could do 0.619 times 52. And that tells us that it's 32.2 weeks. Or we could do 0.619 times 365, and that would tell us how many days this was invested for. Which is 225.9 days. So 226 days. Now, you don't have to do all of these different amounts. You could just leave it as 0.619 years is equal to T, that's fine. But if you want, the question might ask for you to do something else, or if you want it to make sense to you in a different way, then you can convert it to one of these other ones, that's fine too. Now you can do these support questions on page 6, questions 1 through 4. So let's do a few practice questions. Number 1, Mac invested $525 at 7.3% per year. When the investment matured, she had a total of $576.10. How long did Mac invest for? So now we have a word problem, a whole situation, and we need to figure out what information we have and what information we need to answer the question. So what I like to do is I like to write out my variables or what I know. So here, Mac invested $525. So that means that's the principal at 7.3% per year. So that means my rate is 7.3%, which is equal to 0.073. When the investment matured, she had a total of $576.10. So that's actually my amount, right? Because that's the total amount that we have. It's not my interest. And the question is, how long did Mac invest for? So I'm looking for T. So with this information, A, R, and P, can I figure out T? No. First, I need to figure out I. So to figure out I, we're going to do, well, the amount is equal to principal plus interest. So that means that amount takeaway principal is equal to your interest. So $576.10, take away $525 is equal to your interest is equal to $51.10. Is equal to your interest. So now I have the information that I need so I can calculate for T. So now I can use I equals PRT. So I is $51.10 is equal to principal, which is $525 times your rate, which is 0.0R73 times time. So that means that 5110 divided by 525 times 0.073 is equal to time. So using our calculators to do that. So it's really important to read the question and make sure you are answering the question that is given. If we just said 51.10 years, that would not. Now I looked and I'm like, this is a really small amount of time. That doesn't seem right. And if I go back, you can see, oh, I missed a decimal point. So it's important to pay attention to things like that. So make sure that your answer makes sense. That's super important. So this is 1.33. So 1.33 years is, we could also say, is 1 year, and 0.33 is a third of a year, so 4 months is equal to time. That's how long Mac invested. Number 2, Archer owes $2,638.94 on their credit card. If the annual interest rate is 19.99% and they don't pay off their balance for 60 days, how much interest will they pay? So this is a debt. So even though it's a debt question, it's the same process. So first we're going to say, okay, well, we are looking for, we have the principal. Principal is how much Archer owes at the beginning. So $2,638.94. Okay. So the annual interest rate, so that's our R, is equal to 19.99%, which is usually what interest rates are for credit cards. So that's 0.1999. And if they don't pay off their balance for 60 days, so that's our time. So our time is 60 days, which means we have to do 60 divided by 365. Now this, I would assume if I did 60 divided by 365, I'm going to get a big long decimal. So I'm just going to leave it as this fraction in order to make my answer more exact. So then how much interest will they pay? So we're looking for interest. So that means that we get to just use the formula. So I equals PRT. We're looking for interest. So we're going to do principal, which is $2,638.99. Writing down my variables I find can be really useful because then I don't have to go back and comb through my question every time. I do that once, and then my information is just there for me to pull as I need it. So then I put it into my calculator. $2,638.99 times 0.1999 times 60 divided by 365 is equal to $86.72. So therefore, Archer will pay $86.72 in interest. Often your question will say answer with a sentence. And this is all, or statement, this is all that they're asking you to do. It's just to make sure that the numbers, so that you understand what your numbers mean. So you can interpret, you're not just following blindly steps or following without, sorry, I shouldn't use ableist language like that. You're not following steps without a comprehension, but you are understanding what it is that you're doing and why you're doing it and what your result is. Number 3, Oliver hopes to earn $100 in interest over 18 months. If the interest rate is 3.2%, how much do they need to invest? So this, let's see what we're hoping to earn interest. So that's our I of $100. We have our time is 18 months. So 18 divided by 12 is, sorry, I forgot to put months, so I know what I'm doing, is 1.5 years. Our rate is 3.2%, which is 0.032. How much do they need to invest? Oh, that's your principal. Principal is what you're looking for. So then we do I equals PRT. So we know how much interest we want, which is 100. Our P, we don't know how much we need to invest. Our R is 0.032. and our time is 1.5. So P is going to be 100 divided by 0.032 times 1.5. And then we do that on a calculator. And we get $2,083.33. So Oliver would need to invest $2,000. Sorry, $2,083.33. Number 4, Mirabelle earned $6.16 on an investment of $1,000 over 90 days. What was the annual interest rate? So again, you can see these are very repetitive, but it's important to be able to pick through the question and figure out what it is that you know and what you don't know. So Mirabelle earned $6.16, so that is our interest. On the investment of $1,000, well, that's our principal. Over 90 days, well, that's our time. So 90 days, we're going to need to convert into our years. And again, I'm going to just leave 90 divided by 365 instead of writing it out as a decimal. So what is our rate? So when we first did these, we just had random or seemingly random numbers with no context. And it probably seemed, well, why are we doing this? But now you can see various situations where folks might need to know different things in order to figure out what they want to know. So as you can see, the math is fairly straightforward depending on whether or not you're doing principal, rate, or time. They're all the same. You're dividing your interest by the other amounts that you know. But you still want to practice and still make sure that you are paying attention to figuring out what it is that you need to know and what is information you have. Okay, so we do this on a calculator, $6.16 divided by 1,000 times 90 divided by 365 is 0.0249, so 0.025. So that's going to be 2.5% is equal to your rate. So the annual interest rate is 2.5%. There we go. So another way that we can have this formatted is we can just have the information, we can have like a situation and a context, or we can have a chart like this where we are given some information. So here, these amounts are all your principal. These amounts are all your rates. These amounts are all your years, and these amounts are all your interest that you've earned. So this just shows you another way to organize your information. Oh, I didn't do what I wanted. Okay, so we're going to do a couple. So here, for A, I know that my principal is 700. I don't know my rate. I know my time is 2 years, and I know my interest is $112. So you can write out all the steps like we've just been doing. I'm just going to quickly, if I can find my pen, there we go. So our rate is equal to $112. So that's our interest earned divided by 700 times 2. Oops, is not what I wanted. So $0.08, which is equal to 8%. So the same idea for each of these, you're going to figure out what it is that you're trying to find and do the steps that we've just been practicing. But I wouldn't, as you can see, writing it in the space is really cramped. So either if you have really small writing, go for it, or maybe write your steps somewhere else and just put the answer in at the end, which is what I probably should have done. All right, let's consolidate what we've learned today. So this is lesson 6, which is simple interest and linear growth. So remember, simple interest is both an arithmetic sequence and linear growth. It's when the pattern increases or decreases at a constant rate of the same amount over and over again, adding or subtracting it. The formula is I equals PRT, where I is your interest earned in dollars, P is your principal amount in dollars, R is your interest rate, it's a percentage as a decimal, and T is your time in years. Also, A equals P plus I, where A is your final amount. So your principal plus your interest is how you figure out your final amount. So hopefully you can explain the connections between simple interest and linear growth and arithmetic sequences. And you can identify what information is available in a real life situation involving simple interest. And then you can also calculate the missing element, which is what we've done for most of our practice problems. And that's what we've done today. As always, if you have any questions, please reach out and connect with me. This is what I'm here for, to support you in your understanding. Give me a call at 807-737-1488, extension 2209. Call me toll free at 1-800-667-3703. Send me an email at bronwyn.slate@nnec.on.ca. Connect with me through Facebook at bslate Wahsa. Our YouTube channel is bslate Wahsa as well, and there's a playlist called MBF3C, which has all of our current, most recent lessons, as well as previous lessons, as well as other support videos, things that you might need that might be useful. Thank you so much for joining me today. I hope you have a lovely day. Miigwech.